Now, if you use the Quantum.js plugin that we installed before, you can call it from here. This is the interface. It's asking you to select a temporary folder to make all the temporary files. So you can select ctemp. The projection, select always a projected coordinate system that is valid for your country. In this example, I select Ghana National Grid. Then you can select the country code for your country and the name of your country. Population raster, you select the population raster. The boundaries, your polygons of the boundary of the country, and night lights, your lights satellite image that is clipped for Ghana in this case. Threshold, this is a parameter that you need to define how big your cluster are going to be. And basically, if you select a very small number, you can have a lot of cluster because a lot of is going to include all the population that is very close to zero. If instead you select a threshold that is higher, you have less cluster, so less polygon at the end. Okay. So what happened here, then you click OK, is a slow and consuming process. So if you have a very low threshold, a very big country, and a very high resolution in terms of population raster, this will take considerable time. Maybe with a good laptop, the one that I'm using could take even 10 minutes, 15 minutes, 20 minutes. It literally depends of a lot of factors, including your hardware and including your the characteristic of your input data. Once the process is completed, if you don't have any issues, you get something like this. Let's see. Let's see this example for Nigeria. This example for Nigeria is very detailed. I can show you. Okay. So as you can see, now the map is loading. As you can see, a lot of black and white. What we are looking at, basically, a lot of tiny polygons. So if you zoom in, you can see that it looks like a raster, but actually you see every little dot represents every little spot on the previous map is represented by a polygon. What are these polygons? You click with the identify button. As you can see here, basically that every polygon has some information that telling you how many people are living within the polygon and how many of them have electricity according to the estimation, and the estimation also of the intensity of the night lights according to the input data that we selected. Okay, so this kind of level of details is very important because it can give us a more accurate estimation as an output from the model, but is also time consuming and could also increase the likelihood of crashing the system because you have a lot of polygons here. Let's have a look. You can see the attribute table here. You have 700,000 polygons. Okay, so here for every polygon represents a small of or a big amount of population distributed in Nigeria. Okay, this is how you can create this type of cluster polygon. If you have instead something that is in terms of population that is less accurate, you have a spatial resolution that is lower, or you want to create cluster with a higher threshold, you get instead something like this. This one is for Equatorial Guinea, I think. And you can see that the software is much more quicker, and also when you run OnSSET, you're gonna get the result much more easily. Okay, so here is where you should decide your level of accuracy. And again, getting this input layer is not trivial, because you have different steps to complete before getting this layer in the proper format. Okay, so in this example, you see that this cluster is big, but also it works. So if it's our purpose to have a population layer for so I have my zoom interfering. Here it is with the cluster. Okay, so let's see. No, it's not updating here. Yeah, there it is. Sorry, here. So you see that this is in this big cluster. You have a very high amount of people living in this area, while in other cluster you have a very small amount of people. Okay, so this is the input data of OnSSET that we are preparing, but also we are setting the format of the output data. So this table, let's see this table for Equatorial Guinea. Here you have only 3,000 record. Every record represents a cluster of population. So OnSSET will analyze and create all the output based on this table. So if you have 700,000 population cluster, you're going to have 700,000 record in your output for each scenario of OnSSET. If you have 3,000, you're going to have 3,000 record for each scenario of OnSSET as an output. Okay, this is important because some consideration that you need to make before running OnSSET, because let me see if I can pull some output here easily. Yeah, the scenarios for with a high resolution and with a low resolution, you have different output. Okay, so here I have some example of output